Now we are going to see active filters, and I change my OBS settings to 60 fps, and I think that it will make my videos better quality. Now let's continue. Active filters. A low pass threshold. A filter is a circuit that passes certain frequencies and attenuates or rejects all other frequencies. The passband of a filter is a range of frequencies that are allowed to pass through the filter with a minimum attenuation, usually defined less than -3 dB at a critical frequency. Passband is normally specified at the point where the response drops to -3 dB, zero form passband response. Okay, the passband is where the frequency that our filter allows to pass. For example, if our characteristic is like this is a passband from here to here. This is a passband, and the critical frequency is the frequency where the response drops to 70 point, and this means that input output voltage will be 0.707 part of input. This means we in multiplied on 0.7 is we output. Also 1 over square root of 2. A low pass filter is one that passes frequencies from DC to critical frequency and significantly attenuates all other frequencies. Okay, low pass filter, it suggests name that this is frequency and this is amps, for example, amps, and here is zero frequency in this part, and it is something like this. And they said that from DC to FC, this is something FC, critical frequency. It allows to pass signal from in this area. We start, the graphic will be something like this, because it's low pass filter, and it won't filter low frequencies because it's DC, and it will filter higher frequencies. It will filter higher frequencies. The passband of ideal low pass filter is shown in the blue shaded area figure. That's right. This is passband, and this is cut frequency, critical frequency. Bandwidth is equal to critical frequency. The ideal response shown is not. Actually, filter responses depend on number of poles. The term used the filter describes number of RC circuits contained in the filter. RC circuits, number of RC circuits is very important, because this circuit on other RC circuit, this circuit acts like a load, you know, and that changes something, and we'll see what does it change. Then show 50. a single pole it rolls off minus 20 decibel over decade. Beyond the critical frequency, its actual associated line. Notice that gain drops slowly until the frequency is critical. After this, the gain drops rapidly. Okay. The critical frequency of low-pass filter occurs when Xc is R. High pass is different. It starts like this because it won't let pass low frequencies. It passes only high frequencies, and that's why this graph has this okay, roll off is same as low pass filter, it's minus 20 decades. Band pass filter is consisted by two filters, low pass and high pass, and they pass when they have something like this and something like this. This is a bandwidth pass. Okay. Butterworth has got something like this. This means here is no ripples and transition is fast. Bessel has no ripples but transition is slow. Chebyshev has got ripples in the passband but the fastest transition. That's right in here. Okay, about the ripple number, we have got Chebyshev filter, for example. This is some. This is okay. Chebyshev filter, and this is something like this. Here is ripples, and it drops. This is passband. PP passband. And the roll-off time transition from passband to stopband happens fast, but in the passband there is transitions. The faster transition, if you want, you can. You have the many number of ripples. For example, number of ripples in is n over 2, and that n is what's n? What's n? I don't remember what's n. The Sallen key is one of the most common configurations for second order to pole. This is second order because we have got two couples of capacitor and resistors. It is also known as voltage controlled voltage source filter, as low pass version of Sallen key filter is shown. Here is low pass filter and here is high pass filter. On what? Low pass filter and okay. Low pass filter goes. Okay, this gives a gain, and active filters are filters used using op-amps, and op-amps have got that advantage to the passive element filters, because they give a gain to the output signal, has got some gain. Oh yeah, that's n is a pole number. For example, we have got two. If we have got two pole, then the voltage drop will be the roll-off will be minus 40 dB. That means that output will be 10% less, I think. This is formula, and if we had R here, that formula had to have the phase of RB, RJ, for example, has to be in parallel. RJ, RB in here would be parallel. Excellent. 5, 6, 6, 6 couple and 6 120. Yes, it's 100 decibel.